Welcome back. In this video, we're gonna solve this problem that's coming from Berkley math competition. I think it's tiebreaker. So here we wanna find the integral between 1 and 2 of the arctangent of x plus arcotangent of x. So we have the inverse functions of tangent and cotangent, and we wanna do the integral between 1 and 2. Here, this is a time limited question. Very simple if you know this value here. So this value here is constant. So if you know that the tangent inverse of x plus cotangent inverse of x is pi over 2. So we can go and solve quickly here. So we have the integral between 1 and 2 of pi over 2 dx. This is pi over 2. And here we have x between 1 and 2, therefore pi over 2, 2 minus 1, that's 1, so pi over 2. So the value here is pi over 2. So if you know this value, here, you can quickly solve. But what if you don't know here? This is a problem, okay? So we have to prove this result here. Okay, and to prove that this one here, so we're gonna prove this result here for those who don't know this. Okay, so let's define a function. We're gonna call it f of x. So it's gonna be arctangent of x plus arcotangent of x. Okay, so here this is tangent inverse of x plus cotangent inverse of x. Okay, and here we see our function is defined for all the reals. So x can be any value, okay, or we can say the domain of definition of this function is the whole set of real numbers. Okay, we're gonna differentiate, so we need to know the derivatives of the arcotangent and arctangent. Okay, and that's the key to solving this question. Okay, we know that the derivative of this one, the arctangent of x is 1 over 1 plus x squared. Okay, and the derivative of the cotangent inverse is minus 1 over 1 plus x squared. So when we add these two here, so we have f prime of x is 0. Okay, so the derivative of 0, what does it mean? That means our function f of x is just a constant c. Okay, so no matter what values we give to x, we still gonna have a constant. To get this constant, we can find a specific value that works for us, and we find c. Okay, here we can plug 0. We know the arctangent of 0 is 0, but the arcotangent of 0 is pi over 2. Okay, and here we see that 0 plus pi over 2, and therefore we have pi over 2. So if it is constant for one x, it's constant for any x here, because it's a constant here. Remember that you have a constant function that looks like this. Okay, no matter what values you give to x, f will be the same. Here we do it for one value, for x equals 0, and that means f of 0 is pi over 2. That means our c is pi over 2, and therefore our function here, which we called f of x, is pi over 2. Okay, and this is the key to solving this question. Okay, so that was an easy question, but the knowledge of this idea would definitely help. And I know the guys, they know this one here. So here we know we proved this one. We know that the derivative of the arctangent is 1 over 1 plus x squared. What about the cotangent inverse? Okay, so the key idea here that we can prove it in the same way as we do for the tangent. The only exception is that here this is defined on R and it has values between 0 and pi. This one is defined on R, and it has values between minus pi over 2 and pi over 2. Here, we can see that if we let y equals the arcotangent inverse, or arctangent of x, or cotangent or inverse of x, we can find it by implicit differentiating. It's very simple, and we get the result here. Therefore, we have these two. We know this one. This is very simple to prove. And when we add these two, we get 0. And therefore, our derivative is 0 everywhere. That means our function is constant. And we get a specific value, which we have either 0 or 1. But we choose 0. And this gives us pi over 2. That means our function is pi over 2. Okay, I think that's it. That's all we can say about this integral. This is from let me say, what year is this? I think Berkley math competition tiebreaker. I think 2018, if I remember. I think 2018. Okay, if you wanna go there and see. So this is the solution.